Good morning, Kipsters. I wanted to go ahead, or afternoon, or whatever it is. I hope that you're having a great moment. If not, take a breath and change it. I'm going to be teaching in this lesson how to explain the volume of a cylinder, and it's important because we're going to be finding the volume of a cylinder soon. So if we just understand where the volume formula comes from, we really don't have to memorize it. We just have to understand where it comes from. Okay? Let's get started. So this is a cylinder, and I want to tell you that a cylinder is found many parts in the world. It comes in cans, all shapes and sizes. It comes in candles, and it even comes in cars. You've heard like 4-cylinder engines or 8-cylinder engines. Um, so that's it's many places in the real world. But I want to explain two important parts of the cylinder. The first part is the base. And when we talk about an area of something in geometry, I'm going to call it big B. So this is big B. All right? It's different from small b. Small b refers to like lines, like the base of a triangle or the base of a rectangle or parallelogram. But big base refers to the area of the cylinder or whatever prism. The other thing is the height. The height is the connector between the two bases. It helps us measure how many or how tall this is or how wide it is. So the base also tells you the area of the slice of the cylinder. And if you notice in this picture, when we start to stack a whole bunch of slices, almost like if I was to stack a whole bunch of quarters, it turns into a cylinder. And that tells us, the height tells us how many cylinders, or sorry, the height tells us how many bases that are each 1 unit big are in the cylinder. So in this case, the height would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this height would be 9 units long. And ultimately, this forms a cylinder. Now, if you understand that the cylinder is made up of a whole bunch of just bases, it will help us find the volume of the figure. So the volume of a cylinder can be found by finding the area. That's the first step. You have to find the area of the base. It's area equals pi r squared, and that formula looks familiar because that's the area of a circle. The second thing, after you find the area of the base, you multiply it by how high it is. So the number of congruent bases. And it's important that the bases are congruent. Every base has to be the same. When I'm stacking money and I wanted to make one congruent stack, I stack a whole bunch of quarters. I'm not going to stack a quarter. I'm not going to, on top of that, stack a nickel or a penny or a dime. They all have to be congruent. So it's important that when we're multiplying by height, we realize that we're counting the number of congruent bases. So I have a question for you. This is a rectangular prism, and more specifically, it's a cube. I want to know which one of the rules above, 1 or 2, is broken by the figure. Okay? So which one of the rules above does not apply to this? Is it finding the area of the base is pi r squared, or is it multiplying by the height of the number of congruent bases? Go ahead and put your input in. Well, I can find the area of this base, and I realize that this has slices just like the cylinder. They're all congruent, so that helps us. So I believe that it doesn't break rule 2. But the problem is that we don't find the area of a square or rectangle by multiplying pi r squared. That's only for circles, so it breaks rule number 1. The volume of a cylinder can be found by, and there's the two rules again. I have another question. Which one of the rules above is broken by this figure to the left, and why? Is it finding the area of the base, or multiplying by the height the number of congruent bases? So this one's interesting. So the base is still there. This is a cone. And I can still find the area of the base, which in order to find the volume, you'll need that later. You'll figure out the relationship, how to find the volume. But I want you to think about if I sliced this, it would look more like this. And so we know that we can find the area of the base as pi r squared. That's true. The base is a circle. Look at the blue base, and I can do pi r squared. But the number of congruent bases, I mean, they're not congruent. They change in little, and they get smaller and smaller and smaller until they're one teeny point. So I have some questions for you. First question, which one of the following is true about cylinders? 1, 2, 3. Number 2, read the following statements. The height tells how many congruent circles there are. The base is a equals base times height, and the bases are a equals pi r squared. Which of the following statements is true? And how can you find the volume of a cylinder? Alright, Kipsters, hopefully you enjoyed this lesson. I'll see you when I see you.